Calculus 1 students. So we're going to do the last example in the section 4.3, which is asymptotes and curve sketching. So I think I named my last video with 4.3 as well when I was talking about the shape of a graph. This is a mistake. It's just because don't forget that my sections don't follow exactly this two word. And here, this is a different problem to ones that we've covered in class simply because I'm giving you already most of the information. So half of the work is pretty much done. What we need to do is then to take all of this information to sketch the graph of the function. So before we continue, which part belongs to the sign chart and which part does not? This is actually important. So the part that does not is this. Okay, so these two things. Okay, and here my color code. I will just put like in orange right here. That is not part of sign chart. And what does it mean? It means that we can actually use this information right away before doing any kind of sign chart. And to the contrary, both of these statements rely on you having done a sign chart. Okay, so here you go. This relies on sign chart. Or let's just say that it's part of the sign chart. Okay, so these two statements. So why do I say this? It's because we will begin the problem by using these two pieces of information right away, and then we will move on with the sign chart and fill in the gaps. Okay. So first of all, let's have a look at this. Continuous on the real line from -3, like it's continuous everywhere except at -3 and 3. So what does that mean? Okay, well, let's have a look actually at the sign chart just a little bit, just to notice that the last value that we need to sketch is pretty much 5. Okay, so we're gonna first do the graph, expecting something like I'm gonna push it like this direction. So I'm gonna do it like at the bottom like this. And we're gonna expect 1, 2, 3, 4, 5. And then, okay, well, fair, we can have like 6 over here. And then same thing here, -1, -2, -3, -4, -5. And then that's it, like moving on this in this direction. Okay, so we need these. So this is where the important stuff is happening. And now, okay, so we are not told any value of y besides 0. So what I would do here is first I wouldn't like scale my y-axis yet. Unless I hit a part that, actually this part is relevant, right? The limit at -infinity must be -4. So yeah, let's include that information right away, okay? Because it does affect the scaling. So we have -1, -2, -3, -4, okay? And as you can see, this is an asymptote. So let's actually color code the asymptotes in red. Okay, so the limits, they will give us our asymptotes. So we know that we have like a horizontal asymptote over here. Do not sketch it all the way through, okay? Just like on the right part. And okay, so we know that it's continuous everywhere on until -3 or 3. So that also indicates some kind of discontinuity here. But we are also told that as x is approaching 3 from below, f is approaching infinity. So it means not only we have a vertical asymptote here, but we know that the function is somehow like blowing up, okay? So something that looks like this. But we don't have any information on what's happening after. Probably we will have to rely on the sign chart on this. Okay, so, oh, the odd part. The odd part, let's actually take care of it at the very end because as you can see, we have information to sketch the function on this part of the graph. And the fact that it's odd, the function is odd, will allow us to then sketch the graph on this part. So let's move on. F of 0 equals f of 2 equals 0. As you can see, these are placements. That's perfect. Okay, so I'm going to actually go ahead and f of 0. Okay, so we know that this is 0. And f of 2 is also 0. So let's put it here. Okay. And I think for now we're done. Okay, so for now, it's the only thing. Oh, negative 3. Let's go ahead and sketch the asymptote at negative 3. Although I kind of need the odd part to do this, so I'm going to wait. Okay, let's move on to the sign chart. All right. So the sign chart that I'm going to make turns out to actually be a summary chart. Okay. And the reason is because really we have everything, right? So let's go ahead and build up the summary chart. How does it work? Well, okay, and then on this part we have we will put the information on f prime. Then on this part we will put the information on f prime prime. And then finally, we will put the information on f. Okay? So, oh, and by the way, I will also give a fourth line, and you should probably know why at this point. It's because I will combine the information that I have on all of this. Okay, so which critical values or possible points of inflection we have? We have 1, 2, 3, 4, 5. How amazing, right? We have almost the worst possible scenario. So here we have, yeah, let's go like this. 1, 2, 3, 4, and 5. Unfortunately, we don't have anything afterwards. So, and don't forget that this sign chart is starting at 0, right? So we have like 0, 1, 2, 3, 4, 5. Now, reading the information on that line, so what we're going to get is that this, okay, so f prime is bigger than 0 from 1 to 3. So we're going to have like plus, plus. We cannot say much about what's happening at 1 and at 3, so let's keep it at that. And then it's going to be smaller than 0 from 0 to 1. And then from 4 to infinity. So we just fill in second line, right? So this is from second line. From second line. Okay, so I'm missing a little bit of space. I want to be able to sketch the graph here. And then we use the third line to fill in this part. So from 2 to 3, it's going to be positive. Okay? And from 5 to infinity, it's also positive. And everywhere else, from 3 to 5, it's going to be negative, which makes me think that, yeah, we have some information missing over there. So, oh, okay, so 0 to 2 was supposed to be there. Okay, so let's just erase this and correct it. So, from 0 to 2, union, and from 3 to 5. Yeah, so it was missing information. You need this in order to be able to do the problem. So, all right, so here, okay, so we know that the second derivative is negative. All right. Now, what does it mean in terms of the function? Well, you just combine the two pieces of information. So in this case, it's going to be decreasing and concave down. Then it's going to be increasing concave down. Okay, so you just pretty much like read both lines. Then it's going to be increasing concave up, decreasing concave down. That's going to be a funny thing. Unless I messed up somewhere. But no, I didn't. It's totally fine. Then it's going to be decreasing concave down. So it doesn't change any behavior over there. Ah, it's here that I messed up. Okay, so it's going to be positive here. There we are. Which means that here it's increasing concave down. Okay, I was surprised actually. There we go. Then it should be fine now. Okay, so and finally it's decreasing concave up. All right. Now once we have this, now we're ready to actually combine these two pieces of information, right? Using the crossbreeding technique. So here in this case, it will look like this. Then it's going to look like this, 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 and this. Okay? And here we go. We are starting. Oh, one thing that I forgot mentioning is where do we have max, min, point of inflection? So it's kind of obvious as you read the summary chart, actually. But let's go ahead and fill in that information because I believe it's quite important. So, all right. Here, so we will have, so here we have a 0. So in this case, we have a min. Okay. Then over here, the concavity is changing. So we have a point of inflection. Here, the concavity is changing again, point of inflection. Here, it goes from increasing to decreasing. So we're getting a max. And finally, here, we're changing concavity. So we have a point of inflection. There we go. Oh, one thing that I forgot to mention. This is not a point of inflection. This is our asymptote, like we saw it before. So there we are. We have our asymptote there. All right, we're ready. So min, it could be anywhere. Okay, let's put it here. Okay, so this is our min, let's say. Then we know that at 2 it is 0, but we also know that this is a point of inflection. Okay, here we have our asymptote. So let's just write AS, like as we should. Now at 4 we have a max. Okay, and where is that max? Well, okay, so now read the information that's a little bit after. It has to decrease to the asymptote that's over here. So the only thing we really know about the max is that it's above the asymptote. So let's put the max over here, let's say. And then we have a point of inflection at 5. So this will be a point of inflection. And then we just fill. So we go like this. Okay, so then point of inflection. There we go. Then we go increasing concave up, but then, oops, as you can see, we are hitting the asymptote. So we're going like this. All right. Now, okay, so where do we start back? Well, after the asymptote, we have to be decreasing, which means that the curve will pop out from there. So we will be like increasing until the max and increasing concave down, as you can see. Then we're going to be decreasing and concave down. So going like this. And then finally, we are decreasing but concave up. So we smoothen like this until we reach the asymptote. All right, now what's going on over here? This is where the odd comes into play. Okay, so now the odd that is here, that's what we're going to sketch. Unfortunately, I think my colors are a little bit all over the place, so I'm going to sketch it in orange. What does odd mean? It means that you kind of reflect the graph over here and then reflect it down. So in other words, instead of having a min here, you're going to have a max here. So this is going to be your max. And okay, well, I told you you don't need to scale your y-axis, but if you put the min at -2, you have to put the max at 2. That's what it means. Okay? Then you have a point of inflection here. So point of inflection. Then, okay, now you have an asymptote at -3 and you knew that. Perfect. But now you know furthermore, you know that the function will be going down. So you know that the asymptote will look like this, but you know that the function will come back up. So like this. This is your asymptote again. So instead of having a max here, you will have a min there. There you are. And you have to put it under the same y coordinate. Now, I didn't identify it properly, but it's approximately here, right? This is what's important. But this is a min. Now, you have the point of inflection. Again, must be like about in the same position. So about like 3, in other words, something like this. Point of inflection. And now, okay, so as you can see, the fact that we flip and flip back down means that this asymptote at -4 will be instead at +4 when we look on this side. So we're going to go 3, 4. Okay, so this will be the horizontal asymptote. So that's it. Now the only thing we need to do is to reflect, and that's it. So we are going like this, like this, like this. Okay, so it should look approximately the same way, but I mean, I'm not expecting a perfect sketch here. Then this is going on the top like this. Then you're decreasing until the point of inflection, and you're going like this. Cool graph, no? Well, in any case, this is it. So I hope it helped. See you either in class or in the next video.